Imagine you are sitting in a room taking a very complex exam, but there's a catch that you have to take this exam closed book and you have studied maybe months back, right? So if the questions are coming from the recent events or the recent findings, right? You haven't seen them. So now you have just two options. Either you leave it blank in the answer sheet or start guessing, or maybe you can write some fake answers, right? So, well, this is same thing happens with the AI models as well. So, I mean, in the context of LLMs or large language model, their training is basically frozen, or maybe they have like some cutoff date, right? So once we train the LLM, uh, till the training stops, right, their learning also stops. So now, if you think about some questions, if you're asking the LLM, and that is about some recent events or recent concepts, AI will not be able to give proper answer. It might hallucinate, right? Because there is a cutoff for its knowledge. So how do we solve this problem, right? So look at right hand side. You might have heard this term called RAG. Okay, so now you can think about a exam like I say open book exam, right? Where you have the LLM, but you also have a RAG as a tool. Basically, RAG is what? RAG is the retrieval augmented and generation. So instead of forcing AI to memorize the entire universe, we give it a dynamic library. So your company specific PDFs, databases, or some secure pages which you cannot provide as a training data set to the public LLMs, right? So those you can retrieve via RAG, right? So today we are going to understand how this technology works and why it is saving generative AI and how it is bridging a real gap for the enterprise value, because enterprises cannot provide their internal databases or their files to the trainings data set, right? So and also LLM have a cutoff training date, so they will not be knowing recent things. Now let's understand the why the tech industry is completely obsessed with RAG. See, we have to look at the three fatal laws of a raw LLM. Because, see, first you see that they are frozen in time. Training a frontier foundation model costs millions of dollars and take months. So, if you have some new information available, for example, any new uh, document or new news, right? You cannot simply go and train your massive LLM model for every single time. So, for that, what happens that the moment training stops, a hard knowledge cutoff line is drawn. That's why we are saying that the LLM have the knowledge which is frozen in time and have some cutoff. So also, if you see, right, there's a privacy wall. I mean, out of box, all the models have absolutely zero clue about your internal business logic, because an enterprise, maybe banks or healthcare companies, cannot provide their data publicly to LLMs for training, right? And so there's a privacy wall. Whatever data or like private code repositories or your customer data is available in your company or enterprise, that cannot be given to the AI to kind of learn it, right? So, and also, third thing is the hallucination control. So, because we know that LMs kind of behave when they don't have knowledge, they try to make up a very sweet response. So, to solve these things, right, we use RAG solutions, and because of this solution, we are able to basically augment the knowledge of the LLM and utilize them in the enterprise level. Next, let's understand how RAG is working under the hood. So you see, right? I mean, there are main three aspects as name suggests RAG. So retrieve, augment, and generate. So there are three steps. First step is the retrieval. When a user asks a question, we don't send it right to the LLM directly, because as we already discussed in the previous, that uh, I mean, LLM might not know the latest information, or maybe it won't know about your enterprise documentation repositories, right? So what we do, whatever data we want to expose as a RAG, we kind of store them in the vector DBs as a semantic data, so that when a user query comes, right, so RAG will retrieve that data based on semantics from the prompt, from the user, and then all those chunks, right, which are like relevant to your question, they are extracted from the system, maybe using the vector DB or other things, whatever you want to, how you configure your RAG. And next step, like once you have the tip data which is relevant to the question, we augment, right? So once we find those precise paragraphs from the table stage, the system extract them and kind of glues them to the original question. So whatever prompt user had sent, right? Based on that, RAG was able to retrieve the relevant paragraphs or the information in chunks, and that is being appended to the prompt which we have got from the customer, from the client, and then kind of a this complete context, like, because earlier context was just prompt, now in the prompt you also stuffed the retrieve data or chunks from the system using RAG, and then this is fed to the LLM. So now LLM has a upper edge because they have got the uh, kind of a context-rich prompt, and then the brain of AI read both the question and the attached context. Because the fact, right? Because fact is sitting in the prompt itself, and LM has a kind of a very sharp brain, right? So it will be able to provide you the exact answer based on the your prompt and the retrieved document from RAG. Now, let's see that RAG is just not a kind of a developer concept. It is widely being utilized how enterprises operate across every major vertical. So we will not go, I mean, we'll just see the few examples. Like first one is the customer support. So as you might have seen, like the traditional chatbots, for example, Eva in SDFC bank.com, they operate every digit and very kind of a frustrating, right? So they have just kind of options, and whenever you ask some different question, they will fail to respond, right? But once you build the enterprise RAG-based chatbot powered by LLM, they can instantly look up the customer's specific information in the thousands of manuals, right, and extract exactly what is required. And also in legal and compliance, it is utilized because in legal, we know that the legal teams read the documents which are like a hundred or thousand pages long, right? So their RAG definitely can help and process these massive files and provide the summaries or the impact or maybe whatever the required question or prompt by the maybe lawyers, right? So, and also third one, basically in the enterprise knowledge. So every company, suppose for example, have the HR document side, and if any employee want to get some answers from the HR documents or HR system, right? They have to dig through the HR folders and their intranet files, right? But you have a RAG-based LLM chatbot built, so the employee can ask question directly, and if there is some change happened in recent document, that can be retrieved easily. So, I mean, there are like few examples only. So there are so many examples where RAG is being utilized with the LLM to get the accurate information. So yeah, so I mean, at its core, the ultimate takeaway which I want you to take is that RAG is very simple, right? So true AI power equals the foundable AI model plus your precise data. So you have got your LLM powered from maybe the GPT or Claude or whatever system, Gemini, right? And then the data which you have, right, in your enterprise, you kind of marry them together. So it shifts the AI from a frozen system into a real-time, highly intelligent research assistant, right? So, but here's the catch. What we cover today is just a very high-level conceptual framework. In real world, building a production grade RAG pipeline that is fast, secure, and accurate is incredibly challenging. So there are many steps. I will try to cover them in future. So in case you guys like my videos, so I will try to go into deeper and try to show you how do we develop the RAG-based systems. So for now, I'm hopeful that it will be beneficial to your knowledge enhancements. Thanks all for watching my video. If you're watching still, and yeah, thank you, and see you in my next video. Thanks a lot.